This is the TFI forecast section of my presentation. I will update you on some of the work we've done at Technology Futures. But before that, I wanted to talk a little bit, since we have a lot of new people, about technology forecasting, which is what I do. TFI primarily is we forecast where technology is going. Since a lot of people are familiar with that, but some of you aren't, I want to bore some of you to take a little bit of time to go over what we do. Technology forecasting has been around for decades now, before I was around. It's about performance improvement. It's about forecasting cost improvement. It's about forecasting how new technology is adopted, about how new technology replaces old technology, and what the impacts of those changes are in business and society and so forth. And if you think about it, those types of things are perfect for estimating lives and values of capital equipment that we expect to be in place for a while, especially in the communications industry. It might strike you as strange at first to think about forecasting having something to do with valuation, but if you think about it, the values of everything now is really a question of the future. What kind of cash flow benefits will it generate in the future? How long will it be doing that? What's the net present value of the future? It's all really about the future. And even our basic concept of value, fair market value of two parties with knowledge agreeing on a price, they're really agreeing on concepts of the future in arriving at that price. We don't think really about the past in the value of something. It's really what it's going to do for us in the future. So it really was back in 1985 that somebody actually made this connection in the communications industry between the value and lives of assets in the communications business and forecasting. And we've been doing this ever since. The TTFG that I mentioned goes back to 1985. And of course, things have changed a lot, but the basic principles have stayed. Now, there are lots of technology forecasting techniques, but these are the ones that Technology Future usually uses. Mostly the fundamental models of technology change, especially technology adoption and substitution, which I'll tell you a little bit about. Also, performance improvement curves. We also use analogies a lot. I'll show you some examples of that. And then we do what we call drivers and constraints, where we ask ourselves, what's driving this technology forward? Why is it being adopted? And what's constraining it? And then we ask what the balance of those are going forward and how they'll change. And then what questions from further research does that draw? Often just drivers and constraints alone will help you with a good forecast. And it's surprisingly how often it's not done. And then we have expert opinion. There's formal methods for getting expert opinion. We generally rely on research for that, but there's like a Delphi method as well. So those are our basic methods. What I've learned from doing this over a number of years are the following. Nothing happens overnight. Here in Austin, of course, is a tech city with lots of new tech kids. They were all expecting driverless cars to completely dominate Austin streets like 2 years ago. And I tried to say, that's not going to happen overnight. It's going to take time. It may happen, but things take time. We started forecasting the adoption of fiber optics in the local exchange network in the mid-'80s. We're still making that transition. Nothing happens overnight. We were talking about it when I was at Bell Labs in the early '80s. Nothing happens overnight. But the trends that do happen, if they're fundamental technology trends, they are relentless. The march for more broadband has been going on since I was using dial-up modems. And it continually goes on and on, as we will see in a minute. And also betting against those fundamental trends is futile. I've watched the telephone companies try to stick with their copper for decades now and lose more and more customers and finally have to change to newer technology, just as an example. And happens is that because of that, these trends tend to destroy value in old technology. And again, generally not overnight, it's a process. And understanding that process gets us to what that impact of value is. So the basic models that we use for technology adoption and substitution are the Fisher-Price model. It's also called the logistic curve. And what we're doing here is looking at on the left, we're plotting time on the horizontal axis, percent penetration of the product or service, whatever it is, on the vertical axis. When we reach 100% penetration, we're at the end of the curve. Notice that it starts out pretty slow at first as the new technology is getting on its feet. And then if it's a superior technology, it speeds up in the middle, and then it slows down at the end as we get to the niches of the old technology. So these are some examples historical examples of this process, going all the way back to diesel locomotives and going to office PCs and local area networks. Notice that the steepness of the curve is different. So this is a two-parameter model with B being the rate of penetration. All these have different B values, in other words, different steepnesses, but they have the same curve shape. So we can often use some early data to kind of forecast what's going to happen later. Another model we use is called the Gompertz model. Same basic principles, an S-shaped curve. We're looking at penetration over time. But in this case, the tail at the end is a lot longer than the takeoff period. So it means that late adopters really take their time adopting the new technology. We see this more in consumer adoptions, where consumers have the option to not adopt the new technology if they don't want to. So these are some examples of the Gompertz models for various consumer products, historical. And again, they have different B values, different steepnesses, but the same basic principle. So I wanted to give you an example of these that's from an actual TFI forecast back in the year 2000 at the dawn of the broadband era. And this one actually turned out to be several forecasts in one, which is why I kind of like it. If you look at the graph on the left, the green line is the percentage of households that had PCs. At that time, in 2000, only about half the households in the U.S. had personal computers. You can't really have broadband, back in those days at least, without a computer. So we were interested in how fast the personal computer adoption would go. However, among the PCs, not everybody was online. But note that people, as a percentage of people that had PCs, the red line there showed that among that group, online was really catching on fast. And then among the people that were online, broadband was catching on very fast, the purple line there. So if you multiply the red line percentage of PCs online by the percentage of all households, you get the red line here in the graph on the right that shows the actual online households. And then if you multiply that by the percentage that are broadband, you get the percentage of all households that are broadband households. And that's the blue line here. So that's our broadband forecast. The solid squares are the actual data that we had, based on the curve, the graph on the left. And then the solid line is the forecast, and then the hollow squares are what's happened since. So here's an example where by expanding the trends in the future using the models, the Gompertz and the Fisher-Price curves, we were able to make a very good forecast of both broadband early in the process and online households. This is just one example of where we use these techniques to accurately forecast what's going to happen in the future. Another example is where we made a forecast without any data at all was high definition television. This is a 1995 forecast made in, it should be 1995. We forecast that HDTV would be introed in 5 years. We forecast that it would reach, eventually everybody would adopt HDTV. The black line is the actual forecast. We use color TV as an analogy after doing some research. The black line is the forecast, the hollow squares is what actually happened. So 5 years before the start of the technology, we still managed to come up with a reasonably good forecast. Now you might ask yourself, why in the world would technology futures forecasting for the communication industry, telephone and broadband and cable, well, HDTV is digital. That opened up the opportunity to provide programming digitally over broadband, and therefore, it being high definition, that adoption rate was significant for what we expected broadband to have to deliver, which therefore had implications for what we expected communications to have to deliver. This was still in the period where we had executives from major telecommunication carriers tell me, Larry, we don't see any reason for residential broadband. We think dial-up is good enough. Quote. And this was one of the reasons why, I said, no, you're going to need broadband. That's about all I'm going to say about technology forecasting per se. If you want to learn more about the things I just talked about, new product, this is really an example of new product forecasting. And I've just written a paper just this fall for the Foresight, the International Journal of Applied Forecasting. It's a mini tutorial just explaining the S-curves, including the Bass model, which I haven't talked about. And some more examples. So if you want to learn a little bit more and get some more references on technology forecasting, you can go to TFI-CTFG, the website I mentioned earlier, and go under resources for forecasting, and you can download the article for free. Now, I wanted to give you a quick application to evaluation because a lot of you, that's your primary interest here. And this is highly simplified, by the way, but it gives you a basic idea of how it fits together. The one on the upper left, label number 1, basically the blue line is the new technology adoption curve that I've just been talking about for 10 minutes. If you subtract 100% of the market, that from 100% of the market, in other words, flip the curves, you get the percent of the old technology in the market. So the new technologies has replaced the old technology, and the old is what we're looking for in terms of what its life's going to be. Now, if you just look at that, that basically gives you, as a number 2, a survivor curve for the old technology. In other words, a survivor curve is of what you started with, the percent that's still in place. So that by 2026, we're at roughly, about 25% survivors. 2023, you look up there and it's about 90% surviving. So how do we use this to determine what the survivor curve is for assets in place right now? So right now it's year-end 2023, 1/1/2024. So we really need to look at the survivors as of then, because the ones that have retired already aren't in our sample anymore. So what we do is number 3 is we take the survivor curve and we basically truncate it to the as of date, in this case year in 2023, and then we scale it. The gray part is what's relevant. So we scale it to the 90% that's still surviving in 2023, as shown in number 4, and that gives the survivors as of 2023. Of the ones that are still, of the units of the old technology, they're still in place. Starts at 100% year in 2023. This tracks what's left each year in the future. Now going to number 5, then it just shows number 4 in table form, the survivors for every future year. Trust me, mathematically, if you take the area under that curve, divide by 0.5, you get the remaining life, or more precisely, the average. Because in this case is one big unit, one type of technology, The new technology is pushing it out, not because the old technology is wearing out, but because the old technology is inferior to the new technology. That means it's not age dependent. The retirements are not age dependent, which means that all vintages have the same remaining life from a technology perspective. From a mortality perspective, they have different remaining life. From a technology substitution perspective, they have the same remaining lives. That makes it really easy to calculate percent good, because all we have to do is divide the remaining life by the age plus the remaining life, the classic percent good, and the remaining life's the same for each vintage. So that for every placement year, every vintage year, as shown in number 6, we have the same remaining life, so we just add the age to remaining life, and you get percent good. There you have it. We go from a technology S-shaped curve to a percent good table. Now, if we have mortality as well as technology substitution, it's a little more complicated, because the remaining life is also dependent on the age of the asset, but the math turns out to be exactly the same. And then some of the technology future forecasts and percent goods include other types of obsolescence, like economic and other types of technology obsolescence. But the basic principle connection is this one here to technology substitution. So that's sort of it in a nutshell. I'd like to briefly touch on a subject that's come up. People ask me, especially this year, the year of 2023, the year of ChatGPT, about the impact of artificial intelligence on forecasting. And this has actually been an interest area of mine in TFI projects for about at least 6 or 7 years now. Basically forecasting the impact of AI on forecasting. And I won't bore with it too long, but I'll just give you a little bit of idea where it's coming from. This is basically a subset of product forecasting, product same as service, basically. And basically we have forecasting existing products, which is in the first column, forecasting new products, but routine new products, like another model of a car, or another style of shirt, or another form of Air Jordan, whatever the product happens to be. But just a basic repackaging of a new product. And then we have truly new products like, HK television, 6G cellular, things that are brand new. If you look at the AI literature, there's a lot of work on existing products, very little bit on routine new products, and hardly anything on truly new products, which fall in the category of long-term forecasting. Basically, when you have existing products, you have scads of historical data down to SKU code. With routine new products, you have a little bit. With truly new products, you really often have no data. Time horizon is very short term for the existing and new, months or maybe a year or two. With the new products, we're talking about long-term forecasting. And then what we found is that with AI, starting about 2 years ago, 3 years ago, AI has started proving superior to traditional methods in existing products, appears to be useful in new products, but we're still in exploration stage in truly new products. And that's where my world is, long-term forecasting for truly new projects. So there's no AI in what I'll be showing you. We have done some work in it. I co-authored a chapter in this book that came out on AI and forecasting last year. That's basically devoted to routine new products, not the kind of technology forecasting we do. But I also did a paper last year at the International Symposium of Forecasting in Charlottesville last year, that really asked the prospects for AI and long-term new product forecasting. I have that also on the CTFG website if you want to go look at that. I'm not going to bore you with it at this point. Just the conclusions. We found that some parts of the process, like doing the basic research, coming up with the drivers and constraints, perhaps doing adoption curves, um, finding analogies, that type of thing. AI can be quite useful and used in a forecasting process. Some other areas that we do, but not so much probably. But a comprehensive forecast where you tell, you know, your AI engine, give me a long-term forecast for 16K television, you're not going to get anything. And I don't know if you ever will. I don't know if I'll ever be totally replaced, but I think like a lot of professions, AI will in the future be a big part of our work. But anyway, more research is needed on that. Okay, now on to the technology forecast for 2024. Again, for people that come all the time, this may get a little bit boring because usually we're just putting another dot on the curve from the one we showed you last year with always a few surprises. I'll start with the broadband forecast. We've been doing this since before there was broadband. I was tracking the speed of analog modems back in the 80s, for example. And we noticed that even that followed a very distinctive trend. Technology forecasters will recognize this as a constant exponential growth, a straight line on semi-log paper. And then we posited the same thing for broadband after a little bit of a jump. And it's been following that as we've gone from generation to generation of broadband, that same trend line of constant growth, where now we're at 1 gigabit is very common, and we have 3 big gigabits or multi-gigabit service on the horizon. And then, of course, people are planning and actually deploying technology for 10 gigabit service, broadband terrestrial service. Now, we've always instantiated this in a series of adoption curves for technology generations. And we've been doing this since before there was data, but every year we add the data that comes in. And each of these curves show the percentage of households that have subscribed to broadband of one type or another. It could be cable modem, it could be DSL, it could be fiber optics. This is all fixed connection, so it could be fixed wireless as well, but it would not contain mobile. So the first blue line on the far left is basically all broadband. And you can see that it's followed the forecast that we had before, and then it's slowed down a bit, and now it's picking up again. But we still haven't reached 100% broadband connectivity to this day. We'll talk more about that as the day goes on, but that's where we're at. It does look a little steeper than it did on the curve I showed you before with the broadband forecast, but that's only because the scale is much bigger. And then every generation we've plotted. Now, of particular interest to us is the pink line with the squares that says 100 megabits per second and above. Believe it or not, whether anybody would need 100 megabits per second was very controversial at one time. And I had to beg people to consider even the possibility. Now, 80% of the country has at least that. And if you add in satellite, it's 100% now. So that one's done. The next one of interest is 300 megabits per second and above. That one we're at about pushing 70%. That's offered by both fiber and cable now. And then also we have 1 gigabit generation now, where we're at about 30% nationwide, both fiber and cable. And then if these trends continue like they have in the past, we'll see by 2035, we'll be in a 1G and above world. Now, this is basically the S-shaped curves of each generation for everything and beyond for everything before. We usually turn those into these little bell-shaped curves, which are the actual life cycles that are implied by those substitution curves, using a little bit of simple math shown down there at the bottom. So we see the 300 megabits per second, which most of us have today, has now actually peaked, and we moved on to the next generation. Now you may ask yourself, well, what about the following generation, which is multi-gigabit per second service? say nominally 3 gigabits. That's the little brown line. We don't really have any data to forecast, but by analogy and by that trend I showed you before of progress, it'll pick up as we hit mid decade. By end of 2005, we'll see quite a bit of it. And then by 2035, that'll be a standard. And that would mean even 1 gig service, which we're also proud of, will have a life cycle that will trend down as well. So one way we use this in our forecasting is that if the red line is the curve for the broad 1 gigabit subscribers, the purple line or blue, whatever that is the curve for the homes passed that are required to reach that level of subscribership. But not everybody that you make it available to that you pass subscribes. And so we found that there's sort of a basic relation between the two, that if we can forecast subscribers, we can tell you what you need to be providing to be competitive, to get your fair share of the market, a total market. And so if you're really going to be competitive now in 2025, you need to be providing 1 gigabit per second service. So I thought we'd just pull some data for where we are now. And the top table there shows that. This is from the broadband map, just accessed just a few days ago. And the way to read this is each row of the column gives you the speed up and down, and then tells you the percent of households or housing units, I think it is, that have it available. So 95% of the country has a terrestrial solution now for 25 megabits per second service. Thank goodness. 92% have 100 megabits per second at least. Fiber reaches about 40% of the country at that rate. Cable reaches 83%. Fixed wireless about 40%. Poor old copper cable, the DSL technology is only 5%, but altogether we have 92%. The 250 megabit per second category, 40% for fiber, 81% for cable, 8% for fixed wireless, although I think we might see that go up, and then overall 88%. For the 1G though, it's about 32% for fiber, and fiber obviously can do a lot more than 1G, but that's what's being offered in some cases. Cable's at 12%, but there's nothing basic about that technology. You can't make that essentially 83%, as we'll talk about. Fixed wireless currently is 0 in that category. Maybe Roger will tell us some cases where that's going to go up. And then of course copper can't really get above 100, so that's going to be 0 forever. So putting it on those S-shaped curve charts for availability, it basically says that, well, we're really the little squares show where we are now based on the chart table. So for 100 megabit per second and 250 megabit per second, we're kind of behind the curve. We're actually doing pretty well for 1 gig. Is that ideally it'd be 60, and we're still at 40, but that's only a lag of about a year and going up. So to summarize the broadband, the speeds continue to increase, 300 standard now. We expect that in the near future, multi-gigabit will be standard. Right now, 1 gigabit is optimal. We see that this relentless increase in demand means that deploying fiber and other technologies and upgrading equipment is going to be constantly in the mix. We're seeing competition for wireless now, and there's some real questions about how big that competition is going to be, which I'm sure we'll talk about a bunch. And then I've said this before, I'll say it again, copper's doomed. It has been for years. Hardly need to talk about it anymore. So the next question is, how long will these broadband speeds increase? Experience shows that performance improvement marches on indefinitely as long as two things are there happen. It's technologically feasible, and there's a market for it. And based on what I've seen in forecasts and things I've talked about in the past, I think this will go on at least till, through 10K. After 10K, don't know, but through, not 10K, 10 gig, 10 gig. I try to keep my forecasts in the realm of, science and or business as opposed to blue sky too much. But 10K I'm pretty confident about. So another forecast that we make a lot and really started forecasting before it was even when Netflix was still sending anything in boxes, is streaming TV versus traditional TV. And this shows the percent of viewing hours that we spend on each based on historical data from Nielsen. They have lots of paid services. They publish a little bit for free every year. And if this is the chart I showed you last year, 2023, this same time of year, and it showed that streaming was reaching 40%, traditional is down 60% to 60% of the total, and we would have a crossover point, this year or next. So just got the data in for last year. Oops. We're definitely off the trend. It's still trending up a tiny bit for streaming, but traditional TV has kind of kept its own for a year. Then from the forecasting perspective, like several things are possible. The trend has changed. The trend is reaching a climax. There's some weird data glitch, which happens a lot with Nielsen data, by the way, or there's something temporary that's happened. So we look for what it might be. And what it might be that I'm coming up with is the strike, which definitely, put a dent in programming on both sides of the equation, but a lot smaller dent in sports and news, and a lot bigger dent in the streaming programming. And because of that, there's a lot more gaming. So a lot of time people spend on the TV is actually not in this sample, actually went to gaming. So my theory is that we'll get back on the curve, but we're not going to know for sure until next year, or in between. My personal opinion is we'll probably get back on the curve, but these curves mean two things: is that eventually traditional TV will get replaced by streaming. We're already seeing the providers kind of go that way on their own. In other words, encapsulating a lot of traditional TV in streaming, and then Augie will tell us more about the broadcast TV world. But the other point is, it doesn't happen overnight. It's not going to be till 2035, even if I'm right, before this is done. Which means providers are going to have to provide both to the extent that they've been doing that. Now I'd like to move to the HDTV, 4K, and 8K. As I showed you, we've been forecasting HDTV for a long time. That's old news. Now, 4K has been what we've been tracking. It's been adopted to whereas, over 2/3 of households now have an a 4K TV. More and more of the programming's in 4K. 4K, that's significant because it requires more bandwidth from our networks. And then as time goes on, we'll see more and more 4K programming. 8K, the next step, which is 4 times the screen size for the same resolution, or 4 times the resolution, is been out for a few years now. There have been some reports that it may be dead. It still seems to be alive to me, but it's going to be a slow process, just like the previous generations were slow at first. This was the 2023 forecast. This is the 2024 forecast. We've added another data point down here for 8K, staying low. I have put a question mark there now because some people are declaring it dead. Samsung hasn't. They still have a 8K model. There's some people that still say they like it. We'll just have to see. But if it's not 8K, it'll be something that requires more bandwidth. multi-screen or something else. But for now, we're assuming 8K. Why is this significant? Well, if you look at a typical streaming rate, for HDTV, you're talking about 4 meg per second. 4K is about 18 megabits per second. 8K would be about 60 compressed. So it would definitely up the data rates we're talking about. Part of the reason it's going to be slow, though, is programming, the delivery ability of networks to deliver that, and so forth. The key thing here, and Augie is going to talk about this, I'm sure, tomorrow morning, is that it's not that 8K is the most important technology in television. There are lots of things that are important in technology, probably more than the rate, the resolution. But it's the one that will impact communications in the long term. It'll be one of the several things that's going to cause bandwidth to increase in the future. And what are the implications? For cable companies, it means we'll continue to lose the traditional multi-channel TV subscriptions. I don't think anybody's surprised by that. We're taking that into account. But you'll need to provide both the multi-channel and enhanced broadband service simultaneously. We're seeing some competition from wireless, particularly from Steve and others. And the telcos have definitely stepped up their game in rolling out fiber and competing with cable. So we have that. The cable companies are still all in with HFC primarily, the hybrid fiber coax. That tends to be less energy efficient, among other things, so that's an issue. And then one thing, and this is true for everybody in communications, is that you have to increase investment, but because it's highly competitive, you don't necessarily get an increase in revenue. And that's just sort of the name of the game. Turning to wireless, this is our basic wireless forecast based on CTIA data. This is primarily Ray Hodges' work. Subscribership, number of connections continues to go up. Standard connections, meaning our cell phones, have pretty much leveled off. We all have them. Without that means much more penetration to go, growing very slowly, roughly like by population. And then the machine to machine, of course, is where there has been growth and continues to grow. But machine to machine is just a part of the Internet of Things technology, which is only part of the mobile machine to machine. This is the ones with strictly a cellular connection, basically a number attached to it. That's all that's in our forecast. And then, of course, the interesting one that we talk about every year is where we are with technology. We've, of course, talked about 5G at this conference for a long time. 5G finally came. 5G is being adopted. It's not quite at the majority, but certainly getting there. And we forecast it to continue in the future. And you can see each of these generations have had a life cycle. 4G has had its, and now comes the 5G life cycle. We haven't started forecasting 6G yet. Probably will next year, but once we do that, then we'll have a downward curve for 5G as well. So remember I said nothing happens overnight, but things are relentless. This is a good example of that. Each of these generations, last quite a bit of time, almost 20 years. And if you look at the average life for something like a 4G equipment, it's about 9 years or so. Now that doesn't mean there's not technological advance that goes on with in each generation, and there are other function factors of, say, that affect lives of that equipment. But the fundamental life from a technology perspective is about 9 years for this equipment. So what are the implications for wireless providers? Just like on the wireline side, there's a never-ending appetite for bandwidth. We've seen this in spades recently. They're now seriously competing with wireline broadband in some cases. if copper wasn't dead before, now even in the remotest places, uh, there's a there's a wireless solution, if nothing else, satellite. Um, there's more focus on M2M, of course, than there used to be. And then we still have a technology that's greatly improving in cost and performance, which makes everything possible. But that requires continuous investment in new technology and adding spectrum. So it's a never-ending game. So the overall industry assessment is kind of like I told you at the beginning, it's really exciting. We're continuing to see increasing demand for the basic product of broadband. We have to continue to deliver those increases. That means continuous investment in new technology to make them happen. We're doing all this in a really highly competitive industry, and doing a pretty darn good job. This is still an exciting industry to be in. We're delivering a great product to society, and we're helping to pay for the schools. So this is working out. I have just a few minutes for questions. Do we have any questions from the online group? Augie.
Any projections?
We need a mic. Sorry. Oh, can you turn this one on? That's not going to reach. No, he's going to bring you one, I think.
With Elon Musk and Starlink and Viasat, any projections on satellite connectivity, especially as a competitor with other wireless connectivity?
I'm going to let Roger answer that one after the break. What we know now is we have 100 megabits per second offered, which is definitely entry level. And I've not done any forecast myself for the prospects for that going forward. The one thing I will say is that when you think about wireless versus wireline, remember that spectrum in wireless is limited, which means there are capacity limitations. So this, because you say everybody has 1 gig or 100 megabits per second, doesn't mean you can have a large group of users using that at the same time. In fact, you think about all radio spectrum, it's about the same as what you get over a single cable, and less than what you get on a fiber. So you're working basically space division multiplexing that actually lets you
If anybody has any questions, we can put you on the mic.
it's always going to be limited.
Just let me know.
The number of users you can use on a single system. That means that whatever role that plays, is particularly reaching people that are remote, you always have to include the calculation about what the capacity is going to be. Can they really provide 100% of people?
Let me speak into the microphone. If anyone has any questions, I can mic you.
Most kids have learned from their parents really quickly that they need to have a Wi-Fi solution to switch to. And of course, the carriers have gotten very smart about finding ways to make sure they do that so they don't waste precious bandwidth. So that's a long answer to a simple question. A, I don't know, but B, whatever you do, look at the capacity question, because I don't think it's going to put fiber out of business. Okay. Time for another question or two.
Check.
Larry, going back to your streaming forecast, how is it going to be affected by kind of the, Netflix just kind of did a deal with, I think, WWE. You have live sports on Amazon now. So with some of that live TV going over to streaming, how does that affect your forecast?
I'm sorry, I didn't hear, could you amp up a little bit?
Yeah, no, so I was just trying to figure out how much the kind of live sports going on to streaming is going to affect your forecast for the live TV versus streaming.
Oh, live TV.
Live sports going to streaming.
I think that's going to just. If you told me that there was no way TV would ever go streaming, then I would say there's no way those two curves could keep going indefinitely. They would reach a peak. once that we know that sports can go to streaming, then we know that those curves can go on indefinitely. So it won't impact it up, I don't think, because I think it's just already built in.
To give you a data point, the new busy hour of the internet is Thursday evening, thanks to Amazon and live football. And that's what happened already.
Thank you, Roger. Oh, welcome, Ian. 10:01, okay. Unless there's any more questions, I'm going to go ahead and end now because I want to give a full 15-minute break.